So I want to go through a quick calculation to show how compound gear trains work. If we have a gear train here where we've got a 50 and a 20 meshed, that 20 is on the same shaft as another 50 and a 25, that 25 is on the same shaft as a 40, and a 30 is driving the whole thing. Okay, so our 30 is our input gear. The ratio of speeds between the 30 and the 40 is a 1.3 to 1. For every 1.3 rotations this one takes, this one rotates once. For every rotation of the 40, we get one rotation of the 25. And the 25 to 50 is a 2 to 1. So for every 2 rotations of this one, we get one rotation of the 50. Well, again, that 20 is rotating at the same speed as the 50, and this 20 and 50 create a ratio of 2.5 to 1. So every 2.5 rotations of this, I get one out. So, you know, this, I wouldn't say there's a common way of referring to gear ratios other than, you know, what we would say here is that we have a reduction of 1.3 to 1. And that would result in a net gain in torque. So the output torque of the 40 would be 1.3 times greater than the input torque of the 30, but the output speed would be 1.3 times smaller. So divided by 1.3. But when we have a compound gear train, all that aside, when we have a compound gear train, we see that the ratios end up getting all multiplied together. So the 1.3 reduction here, multiplied by the 2 to 1 reduction here, multiplied by the 2.5 reduction here, gives us a grand total of 6.5 when we multiply it all out. Now I've created this gear train over here where we've got a 30 driving a 40, connected to a 25, driving a 50, connected to a 20, driving a 50. And let's go ahead and rotate this here. And if I count the rotations over here, watching the top dot over here, so that is 1 full rotation. That is 2 full rotations, 3 full rotations, 4 full rotations, 5 full rotations, 6 full rotations, and half a rotation to get us back up to the top center position here. So that does work out. Now, that being said, we've got a 6.5 to 1 reduction in speed, but that would give us a 6.5 times more torque output here. And if we ran this backwards, we would see that we have a 6.5 times speed increase if that gear would stay attached. I don't have another nut to put on there, but we can see from the other ones that we have a large increase in speed because of this compound gearing. So big driving small increases speed, small driving big decreases speed. All right, thanks for tuning in.